Okay, guys, I'm going to do this one. So this is phase 22. And, okay, so let me read this. So given that r prime of x is equal to this here, and r of -1 is 12, part A, at what value does r of x achieve its absolute minimum on 0 to 1? And then part B, find the absolute maximum of r of x on 0 to 1. Now, guys, you're going to do two problems like this for the practice. And when you do the two problems, before each of them, please reset your calculator to a 10 by 10 window, because part of what we're practicing here is using a feature called Zoom Box. And if you don't, especially after the first problem, if you don't reset the window to 10 by 10, then you're not going to get practice with Zoom Box, because you're still going to have the window from the first problem. So I want to go to Zoom. So go to Zoom and then down to Standard. And then that is going to give you a 10 by 10 window. All right, so that'll give you a 10 by 10 window. You could also do second plus 712, and that would just reset it. But between your problems, please reset the calculator. Okay, so, all right, so guys, I need the candidates test, all right, because they're talking about absolute maxes and mins. So we need candidates test, all right? So it goes like this. You have x, whatever the input variable is, here it's x, and then over here, r of x. Okay, and then the first number is going to be the left endpoint. The last number is going to be the right endpoint. And then in between them, we need to find the critical numbers. The critical numbers are where the derivative is 0 or undefined. Okay, so the derivative here they gave us, it's right there. And I'm going to show you how to find the critical numbers. So, first of all, guys, my window, I want the x values to go from 0 to, or actually, let me say that later. All right, first let's just graph this derivative here. And you need to be in radians. And I am not right now, so I got to go to mode radians. All right, so on the AP Calc test, you want to be in radians the whole time. Which I think is different than physics, so be careful. All right, so I wanna graph this in y1. So this is, you can go like this if you want, but this is sine of e to the 2x over 15. Let's graph it and see what it looks like. Okay. Okay, now first of all, I want to be, these x values are going from -10 to 10. I only want to consider them from 0 to 1. So I'll go to my window, I'll change this to 0, and I'll change this to 1. So x min to 0, x max to 1, and let's see. All right, and guys, on this interval, I'm looking for the x values where r prime is 0. Okay, I'm looking for those x values. And it's really hard to see like where they could be. So what you're going to do is go to Zoom Box. All right, so Zoom Box. And I'm just going to go like a little bit up above the graph. I'll start way over here. I'll hit Enter. All right, go all the way to the right, but don't go like off the screen. And then I go down, and then I hit Enter again. Okay, and now we have a better view. Okay, so it looks like we've got two critical numbers. We've got two places. This is the graph of the derivative, and there's two places where it crosses the x-axis. Now, guys, there is a way to find the zeros. All right, so I'll find this 0 one way, and then I'll find the other 0 another way. Okay, so this 0 here, I can go second trace, which brings you to the calc thing, and then 0. And then left bound. So this is like right where the 0 is. I want to be to the left of it for left bound. I hit enter. And then I want to be to the right of that 0 for right bound. Enter. And then it will say guess. And then you enter again. Okay, now, guys, I want to store this. All right, I need to store this in my calculator. So it's 0.572. All right, so that's going to be like right here. All right, so I'll all right, let me like write it right here. Okay, 0.5723649. All right, so I'm gonna write that. I'm gonna store it though as A. So you go second quit, you hit X, and look, it's right there. And now I can store it. So I hit store, and I'll store it as A. All right, so it's right there. So this is, so I'll write here like A. Stored. All right, and now I'm only going to have, so now for the other 0, let me show you another way that you could find it. You don't have to do this though. So to find this next 0, I could use the intersection button. It depends on what you like. But in order to do that, I have to graph y equals 0. All right, so see, now the x-axis is also another graph. And so I could go to second calc and then intersect. All right, it just depends on what you like. And then you move close to this, and then you just hit enter 3 times. Okay, so 0.918, all right, so then this one, I'm gonna call it B. I'll store it in a minute, and it's 0.918933. Okay. All right, and then I'll go quit, I'll hit X, there it is, store as B. Okay, now I've got to find these values. So, guys, when they're telling me this stuff, that r prime of x is that, and r of -1 is 12, well, then I can represent r of x as an accumulation function. R of -1 plus the integral from -1 to x, and then in here, r prime of w dw. Okay, just like that. So, this is r of x equals r of -1 is 12 plus the integral from -1 to x, and then in here goes sine of e to the 2w over 15 dw. Okay. Now, because I already have this written down and they defined r prime for me already, I don't have to, when I write my integrals in here, I don't have to keep writing this input over and over. That's just a lot to write. I can write r prime of w. I can do that. All right, so here we need 12 plus the integral from -1 to 0, r prime of w dw. And then for this one, we need 12 plus the integral from -1 to a. I have it stored in my calculator, so I can call it a. R prime of w dw. This will be 12 plus the integral from -1 to b. through, and then this one will be 12 plus the integral from -1 to 1. Okay, and now we're going to find these in our calculator. Okay, so I'm going to go 12 plus math 9 from -1 to 0, and then in here I've got sine of e, wait, sine of, no, I'm doing natural log, whoops. How do I do e? Second, e to the 2x over 15 dx. Okay, 12.027. All right, now for this next one, the only thing I'm changing is that instead of 0 up top, I got to put a. So I'll go second enter. All right, second enter, that brings it back up. And then I can just go up here, and then I hit A. Oh, okay, 12 point, not much of a difference. 12.057. All right. And now second enter, B. Okay. 12.043. Second enter, 1. 12.045. 12.045. Okay, so for part A, at which value does r of x achieve its absolute minimum? What is the smallest of these numbers, guys? The smallest number is 12.027. So r of x is achieving this absolute min at x equals 0. All right, so for part A, absolute min at x equals 0. And then, so there's that. Then for part B, they want us to find the absolute maximum of r of x on 0 to 1. So what's the biggest number? 057, 053, 055. It's this one right here. All right, that's the biggest number. So this time, the answer is absolute max is 12.057 at x equals a. Yeah, okay, I think that's good. Guys, the reason I asked you these questions differently is because sometimes they want to know at which x value the absolute max or min occurs, like part A, and then other times they want to know what the absolute max or min is. So for problems like if they phrase the question like part A, they just want the x value. If they phrase the question like part B, they want the y value.